Okay, we're talking about inequalities, and people did pretty well on this already. Few things that people need to touch up a little bit, and we'll talk about it. Okay. For example, I don't think everybody necessarily did all these things. Right? But most people at least made a good attempt at the solution and drafting the solution. Okay. So that's a good start, but you want to maybe go back and rework the assignment for practice because it's always available for practice. So the first inequality, 3x plus 4 less than or equal to 19. Now I accidentally wrote an equal sign there and people solved it. Then it's all good. I'm gonna have to go back and correct it for less than or equal, but that's pretty straightforward. I think everybody pretty much did that. Okay, so what do we do? Well, people like to subtract equations or add equations. So if we add this equation to this equation, we get 3x less than or equal to 15.
Thank you.
And then we divide both sides by 3. So x is less than or equal to 5. Now, graph the solution. Well, on a graph, you have your x-axis here, and you'd have 5 here. 5 is included in x less than or equal to 5 because x is equal to 5. This is still true. So it's true when x equals 5, we put a big closed dot on the x equals 5. We don't need x equals 0. We don't need 14 or 28 tick marks in this thing. All we need to know is 5. Okay. It's the only number we need to know. The rest of the scale doesn't really matter. Although if you want to put a bunch of tick marks on it, okay, you're taking extra time, but if it, if it looks better to you that way, that's fine. Okay. Nothing wrong with it. Okay. And then actually I'm gonna make that mark blue. And then all numbers that are also less than 5, which are on this side of 5. So we draw a big old arrow here. And there's the solution. Okay. The interval. Negative infinity 5. And now you've seen interval notation ever since the introduction to my open math, where they used it. And a number of people didn't know the interval notation at that point. But you've had an opportunity to become used to it, and it's really quite simple. And I don't think anybody's going to have any real problem with it if they just focus on it. Okay. Excuse me, a little hoarse. This weather's weird. And stays that way until about June. So I'm going to probably be hoarse until June. Okay. Intervals negative infinity to 5. And then I said check. Of course, the check could have come earlier, but as long as we check, personally, I would check before I did all this. Because I find that my check doesn't work and I have to redo all this, right? But this is kind of the order some most people do it in, so anyhow, check. Check x equals 4 when x equals 6. It can be any number to the left of 5 and any number to the right, but I'd use a couple of numbers that are kind of close. Okay. So we check these numbers. We get 3 times 4 plus 4 is less or equal to 19. Well, 3 times 4 is 12, and you add 4, you get 16. And that's true. And that is consistent with the idea that, well, okay, if we put 4 there, it better be true, right? 4 goes on this side of 5. Then if we put 6 over here. I'm doing that kind of small because it's really easy to do, but I'm doing it just so you get to see it. You get 18 plus 4, which is 22, less or equal to 19. It's false, and that is what should be, because when x equals 6, you're not in the solution set, right? So it better not be. Now, if you were supposed to reverse your inequality and forgot to do that, as I saw a couple of people do, at least one, okay, then your check is going to tell you, uh-oh, I messed something up. And the first thing you'd better check is whether you have the inequality right, okay? So anyhow, so we have that. Then we have 5 times x minus 3 greater than 3 times quantity 2x plus 7 minus 4. Okay, well, if we do the distributive law, and I'm going to go ahead and do this. Write out the 5 times this and the 5 times this. I want everybody to do that for a while until I'm sure everybody is using the distributive law, okay? Because it's a really common pitfall and it's really easy to mess it up. You see that 5 in front of x, so you multiply x by 5 and forget to do that to 3, okay? Or the negative 3. It's really easy to do that, especially if you're in a hurry. Okay, so I'm multiplying it out here. What I'm saying is, if you write this out until there's no way that you can skip this step and not imagine doing this, then you're going to be more secure. Of course, if you check your solutions, you can then find out, oh, something went wrong. You go back, you discover you messed up the distributive law. Now you got to do everything again, right? Avoid that. It just, takes what, 6 seconds to write that out. Take that 6 seconds, even if you're in a hurry. I know I'm as bad as anybody, and probably worse, about wanting to move on and skip steps, okay? And not just in math, okay? Try to discipline yourself. You take that little bit of extra time. And then you got 5x minus 15 is greater than 6x plus 21 minus 4. Not skipping steps. Because it's dangerous to skip steps. 21 minus 4 is 17, so we make that simplification. Now what do we do? Well, we want to have x on this side and numbers on this side, right? Constant numbers. Okay, so we're going to subtract 17 from both sides. So we'll do negative 17 here equal negative 17 over here. Then we line up constant numbers with constant numbers. We have 5x minus 3t greater than, because when you add equal things to something that's greater than something else, this is still going to be greater than this. And we've talked about that. Okay. At this stage, it's kind of easy to get stuck if you haven't solved a lot of equations. And you probably ought to go back and work through. It doesn't take long to work through some of these open math assignments for practice. It's not going to affect your grade. You can skip the ones you're sure of and check yourself on the ones you're not, okay? And having done the assignment, it really doesn't take long to do it all, to do another one for practice, all right? So we have this. Okay, so what do? Well, we find that our habit of subtracting the same number from both sides or adding the same number on both sides really didn't get us where we want to go. Okay, now we've got x's on this side, we've got x's on this side, we've got a number here. So, I'm going to think, maybe I shouldn't have done that. Okay, it's okay, I could still recover this. But I could subtract the 6x from both sides and get all my x's over here. But then I'd have a number over here that I'd have to add to both sides. So I'm gonna lightly cross out those steps and go back and say, well, what I should have done is 5x minus 16 greater than 6x plus 17. Okay, that still follows from the step I didn't cross out, well, the last step I didn't cross out. And then I'm gonna say, you know, I didn't want to get the 17 over here because I want my numbers to be over here, right? And I say, so maybe I better subtract that 5x to both sides. Let's try that. Subtract 5x here greater than, sorry, equal negative 5x over here. And my x's go away. I get, never mind, subtract 6x. Sorry. Okay, subtract 6x from both sides, and now I'm going to be left just a number over here, right? And all my x's will be on this side. Well, that's going to give me negative x minus 15 equals 17. Now what do? Well, I have 15 both sides, and you know, thought I got out of both on the right side this morning, but apparently not. And it's greater than, not greater than or equal. And it wasn't equal in the first place. Okay, so there's my result. Okay, did I confuse you? Everybody on track? Okay, so my point is, again, once I get to this equation, I generally want my x's on the left. Now, that's not a hard and fast rule. You could end up with all your x's on the right. But that's not really the way you want to see the inequality, okay? So it's probably more grammatical to have your x's on the left. All right. When I do this, I end up with negative x is greater than 2. Okay. Now, if you want, you call that greater than 1x. Negative 1x is greater than 2. And then we take negative 1x and divide by negative 1, and 2 and divide by negative 1. Now that I've divided by a negative, what's the thing that I'd better do? I better reverse my inequality. Not everybody reverses inequality, and that's the thing. It's really the only place where inequalities are any different than equalities. Okay. So that gives me x less than negative 2. Okay. Now let's see if I manage to do that right. Okay. I intentionally did this, and then I made a couple of mistakes I didn't intend. So, okay, got x less than negative 2, so check. X equals negative 3. That would help if I had a picture of this. I'm going to make a picture. It's going to be kind of small. Here's negative 2. Negative 2 is not included, so I'm going to use a big open dot and an arrow to the left. And I do this so I can see where negative 3 is. Negative 3 would be like here. And it ought to be true. So if x is negative 3, well, I'm not going to do it all, but negative 3 minus 3 is negative 6. That's negative, or negative 30 on this side. That would be negative 6 plus 7, which is 1. And 3 times that is 3, and 3 minus 4. Can't be that close. What's the matter? This is worrying me a little bit because I think maybe I have an error in here. Okay, we'll see. But again, negative 30 is greater than that's 21 minus 4, 17. So something's seriously wrong. Okay. So let's go back and check. Subtract the 6x from both sides, and that's good. Negative 15 was right, and the 17 was right. You get negative x minus 15 greater than 17. I'm still getting that it's all right. That this is a solution. Let's see. I'm gonna have to look at your papers to see how to solve this thing. Y'all are doing good today. I'm really not so hot on this one. And negative 2 minus 3 is negative 5, and that gives me negative 25. That's negative 4 plus 7. Yeah, something's really wrong here. Good heavens. Did something really bonehead here. Not sure how I managed that. Let's see. Go all the way back here. That's going to be 5x minus 15. There it is. It's going to be 6x plus 21. There it is. And minus 4 gives me the same thing. And plus 17. I subtract 6x from both sides, I'm going to get negative x here. 17 and 15 is 32. I don't know what's the matter with you people that you can't do arithmetic. Now I'm feeling a little more hopeful. Okay. I just pretended to make that mistake. So you'd see how what you have to go through to debug these things. So you'll know unmitigatedly why you never want to skip steps and want to be careful with your arithmetic. Take a lesson. Okay, I didn't do that on purpose. Okay, that's 32. So that would be negative 32. So let's change this number here to negative 32, and this one to negative 33, and see if I'm doing any better. And I certainly hope so. Okay. So if x is negative 33, you get negative 36, multiply that by 5, you get negative 108. Okay. I think. Okay. And here you get negative 66, you add 7, you get negative 59. Multiply that by 3, and you get negative 147 minus 4 is negative 153. And negative 180 is less than 153, negative 153. So I think that checks. Now you plug in your own numbers, see if I did that arithmetic correctly. It should get better now when I use negative 31, right? So I check with negative 31, which is on this side of negative 33. You want to have this picture, so you know which side everything is on. That means that one's false. If x is negative 31, then I have negative 34. And you multiply that by 5, you get negative 170. And false, that was true. Okay, you get negative 170. And here we get negative 62 and 7 is negative 55, negative 155, negative 159. So negative 170 is not less. Not my numbers didn't work. Negative 31, negative 62, negative 55, negative 165. I said 155. Minus 4 is negative 165. Over here, we get negative 170. and that's not true. Yes, it is. Check it yourself. Okay. I'm gonna do 32. That's gonna give me negative 35. I know what I did. When it's negative 31, I got negative 35. So that's gonna check out. Okay, I don't want to write out all the numbers because I'll mess them up. There we have it. So we've done everything except write the solution as an interval. So I'm going to write the interval right here. I'm going to write it kind of small, but you should be able to see it. The interval will be negative infinity, negative 32. Okay, how many of you got that solution? Makes me feel a little better. Okay. Now, we went on to a couple of absolute value inequalities, and we talked about this a bit last week. Let me look at this screen real quick. I want to make sure we're getting the bottom of the board. Okay, between Zoom and my camera, I'm not sure which. It might have been that some of this stuff was not visible. Okay. But there it all is. This is just a check on this. And that's very straightforward. Plug in x equals 6. So if we get x equals 4, find out for x equals 6 for false, for x equals 4 it's true. And then similar here. I think everybody could see it down to here. We divided by -1 and had to reverse the inequality, giving us like less than negative 32. Then we did a check, and I found out that my original solution, which left the 3 off of 32, which wasn't a good idea, didn't work at all. So I pretended to make that mistake. Okay, I wasn't pretending I made it. And my check didn't work out. Okay, remember, always check. All right. Good, that was almost out of time. No, we actually have 15 more minutes. Okay. 10 more minutes. 15. Snow schedule. Incidentally, snow schedule. Okay. You can look at the schedule. I don't look at the schedule. Okay. I just remember, okay, we start at 10 o'clock. And every class is an hour and 5 minutes later. So from 10 o'clock, we get 11:05. From 11:05, we get 12:10. Therefore, I was here at the right time for this class. Okay. And of course, I could get, then it's going to be 1:15 and 2:20. And after that, I think we go on to just the regular schedule. That's just a plug for understanding the algorithm, understanding what is going on, instead of reading a bunch of numbers you might read wrong. And then you do both to make sure. That's another check. Okay. Or whatever that's worth. I don't like the way this camera is zoomed now, so I'm gonna make a quick change. Okay. Okay, so change the zoom on the camera, but other than that, everything's what it was. Let's take the first couple questions I asked you. We got absolute value of x less than or equal to 7. Okay, what's this mean? This means that x is less than or equal to 7. I've got an inequality here, and I didn't intend an inequality. I want the equality. X negative absolute value of x equals 7. You get x equals 7 or x equals -7. We talked about y last time. You can't dispute that the absolute value of -7 is 7. You can't dispute that the absolute value of 7 is 7. Well, that's our solution. And then I could write out the solution set. Now, open math, I think we'll just ask it to enter these two numbers with a comma. Okay. If you're writing it out, write out the brackets. It's a solution set. It is a set. Let's indicate it as a set. Open math, wisely or unwisely, and I don't know which, I can see it either way, about 50-50. Doesn't require you to put the brackets in there. Or the braces, okay? That's because you gotta go to the character thing and do it, and it's a hassle. So they want to save you the hassle. I don't disagree with them on that, okay? But when you write it out, write out the brackets. Yeah, the braces, okay? Easy to write them out if I called them the right thing, wouldn't it? Okay, absolute value of x minus 3 equals 5. Okay. Now this means that whatever's in the absolute value sign, it better either be 5 or -5, right? Because the absolute value of something isn't equal to 5 unless that something is either -5 or 5. So we can say that, well, that means we've got x minus 3 equals 5. Or x minus 3 equals -5. Well, then we can solve both of these equations. I also, on your paper, I want to see that or. That logic is really important, and people don't think logically all the time, especially in a math class. Okay? Yeah, logic can be overrated, but you got to be able to think logically, and you got to learn to think logically. And then when you're thinking creatively or illogically, at least you know. Okay? And then as long as you know the difference, you'll be all right. Okay, so anyhow, we solve this, we get x equals 2, so it's this or this. So the solution set is 8, -2. That means 8 and -2 are in your solution. But your solution can't be 8 and -2, because if it's 8, it isn't -2. And if it's -2, it isn't 8. Does that make sense? It can be 8 or -2, so 8 and -2 are both solutions. Okay? That's the difference between or and half the population is unaware of that difference. Okay, so being the half that is aware and reinforce it by understanding the role of or and here, because it's going to be important, especially like next. Okay, next thing is absolute value of x less than 7. Okay. Well, not so fast. What if x is -10? -10 is less than 7, right? Well, if x is -10, what's the absolute value of x? It's 10. Is 10 less than -7? Less than 7? No. So not every number less than 7 satisfies this equation, right? So I can write that not e.g. Okay. For example, x equals -10. Not less than 7. Use a false statement. So you can't stop there. Okay. Well, there are negative numbers that satisfy this, right? X was -3, you'd be fine, right? Because you get 3 less than 7, that's true. Well, what it comes down to is you got to use and here. If I write down what I intend, we'd all be off. X greater than -7, right? If X is greater than -7, then you can't have -10, for example. Okay, now you can think that through, but it has to be both. Okay, so how do you draw that? Here's 7, here's -7. Okay, well, here is the set for X less than 7. And here is the set for X greater than -7. Okay. Now, when I say this and this, I don't mean all these numbers or, oh, yeah, I don't mean any number here or any number here. I mean a number that's both here and here. A number that's both on this side of 7 and on this side of -7. Okay? So the interval that I'm looking for, so I'll put the X less than 7 here, put this interval here, and the interval that I really want is between here and here. Says X has to be less than 7 and it has to be greater than -7. So the solution those parentheses, -7, 7. Okay. Now, this is one way to write out the solution. This is another way. This is probably the way open math is going to ask. But on your paper, I really want to see this logic. Okay, that tells me that you understand this, other than just your following and imitating what you see. Now, if the best you can do is imitate what you see and get the right answers, that's a good step. Okay, but you're much better off if you understand the logic. Okay, so if I wanted absolute value of X greater than 7, the solution would be X greater than 7 or X less than -7. X would either be greater than 7 or it would be less than -7. It can't be both. X can be both this and this. Any X between here and here satisfies this and satisfies this. It's this and it's this. Here, it could be or. Now, the picture of that step. Well, X greater than 7 is here. It's supposed to be an open interval. That little messed up. X I'll be looking left hand side, but that's what it is. X less than -7, okay? It means X can be here or here. Again, this would mean means X has to be here in the yellow arrow as well as in the orange arrow, okay? Which means it has to be here. We don't need an arrow on that because it terminates at both ends. This means X could be here or here. Difference between and or. Now quickly, because the rest is actually pretty easy, and it's a good thing because we don't have much time. What if we had absolute value of 3x minus 6 less than 12? Well, that would break into 3x minus 6 less than 12 and 3x minus 6 greater than negative 12. So you would solve the equations and you would get two intervals just like you do here. You have to go through a couple of steps to do that, but you know how to do those steps. Okay. And let's make sure that looks more like an absolute value instead of 13 or something. And if you had you would break this into two inequalities. It's an or. Okay. The and, again, you're going to get two intervals from the two inequalities. You're always going to get two intervals. And you want to indicate those. Okay. But then you have your interval solution, which is a set of x's that's both in this and this. Okay. If you have a greater than or equal here, you're going to get two equations with an or, and you're going to get a graph that goes to the left of one number or to the right of another number, and there's going to be a gap in between. Okay. So take my words of wisdom on that, and then let open math make you really smart. Okay. Work it out. Understand the ands and the or. Kind of focus on that because you pretty much have all the algebra. But focus on that first step where you break this thing into two with an and or between them. Okay. Ponder it.